Hey guys, it's Miss Johnson, and I'm here to bring you our last little piece of section 4.2. So far, we have talked about observational studies versus experiments. We've talked about the very basis of experimental design with a whole bunch of terms. We've talked about random assignment and control and placebo and all those things. Today, we're going to talk about randomized block design when we block our experiments. So this is just the last little piece of our experimental design discussion for this section. Here's that long list of learning targets, and we're just down there at that very last one. Describe a randomized block design and a matched pairs design for an experiment and explain the purpose of blocking in an experiment. So that's our last learning target for this section. All right, so let's talk about blocking. A block in terms of design is a group of experimental units that are known before the experiment to be similar in some way. So we somehow block groups separately in order to separate out common characteristics that may have a difference in the treatment. If you think back to the observational study portion of section 4.1 and then the very beginning of 4.2, we talked about sampling and how we could have a stratified random sample when we collect a sample and do an observational study. Stratified random sampling was when we would split things into groups of common characteristics. Like, for example, at the high school, I could split students by grade before I randomly select however many students I want in each grade. Or I could split students by gender, or I could split experimental units by gender before I randomly assign them to two treatments. Okay, so a randomized block design is that mentality, but now we're doing it with an experiment instead of with just an observational study where I collect data afterwards. In our experiment, we're going to block our subjects apart based on common characteristics, and then we'll randomly assign them within the block. So it's almost like you're carrying out the experiment separately within each block, okay? So in a randomized block design, the random assignment of the experimental units to treatments is carried out separately within each block. We use randomized block design because it allows us to account for the variation in the response that is due to the blocking variable. This makes it easier to determine if one treatment is really more effective than the other. When blocks are formed wisely, it is easier to find convincing evidence that one treatment is more effective than the other. Basically, you want to remove the argument piece of, is your treatment actually warranted? You're trying to prove that this treatment may be beneficial or this treatment may have an effect. You're trying to prove some sort of effect or show some sort of effect. But if somebody is able to come back at you and say, well, what if it's different for men and women? Set up a block design. If you set up a block design and you split the men and women apart and you carry out the experiment within the group of men and within the group of women separately, then you remove that variable. See, look, I carried it out for both the men and the women and I still got the same effect. So that's kind of what a randomized block design is for. It's to separate out groups of individuals that may have similar characteristics so that you remove that characteristic as a confounding variable. You remove it as a potential source of why the treatment may be different or may be effective or may be ineffective. So here's just kind of a picture, and they're talking about, this is an example of smartphone users. So in this experiment, the two treatments that they want to apply or they want to give to the experimental units are testing out two different keyboards. They're testing out a keyboard A and they're testing out a keyboard B. Now, it doesn't make sense to give the same treatment to people who do or don't use smartphones. If a person is not a smartphone user, you're going to have a lot different results than for the person who is a smartphone user. So that's how they blocked their design. They split their 10 volunteers. They took their 10 volunteers and they split them into smartphone users and non-smartphone users. So then within the smartphone user group, there were only 4. They randomly assigned 2 to each keyboard. Within the smartphone users, there were 4. With the non-smartphone users, there were 6, and they randomly assigned those subjects to keyboard A and keyboard B. But you get it, because they need to see the difference between people who are used to typing on a smartphone or who may not be used to typing on a smartphone. That's going to make a difference in your experiment. So they blocked those two apart. So in an essence, when you look at this, it's like this whole piece right here is its own experiment, and this whole piece right here is its own experiment. And then once you've done the collection, you're comparing typing speeds here. Now you can put your results back together after the experiment has been carried out, and you can compare the adjusted results within each block. So they separated out the smartphone users from the non-smartphone users so that this wouldn't be a variable affecting that. That's the point of a randomized block design. A lot of randomized block designs come into play when you're comparing genders or age groups or things like that. It's really a really nice way to remove that variable as a factor in the treatments. All right, so then randomized block design, there's another piece to randomized blocking where you have a match pairs design. Match pairs is a common experimental design for comparing two treatments that use blocks of size 2. In some match pairs design, two very similar experimental units are paired, and the two treatments are randomly assigned within each pairs. So in others, each experimental unit receives both treatments in a random order. So let me give you an example of a match pairs design. One match pairs design may one experiment, let's say I want to test out the success rate of a review tool that I have. So if I want to test out the success rate of a review tool that I have, it's going to look different between students who score high in my class and students who score low in my class. So what I might do is I might sort my students based on their assessment scores. Then I'll take the top 2 assessment scores and I'll give one the old review method and the other one the new review method. Then I'll take the next group of 2. So that's my matched pair. My matched pair is taking students of same ability level and assigning them to the 2 treatments, and I'd go all the way down. And that's how I get my 2 groups. So it's almost like you repeat the experiment multiple times. If there's 32 kids in our class, I have to repeat the experiment 16 times because I'm blocking kids in groups of 2. So I would take a block of 2 and I'd give one treatment and one the other treatment, then take the next block of 2, give one treatment, one the other treatment. So a lot of times match pairs design comes from sorting people in some way. You could sort them by ability, you could sort them by height, you could sort them by weight, you could sort them by tons and tons and tons of different characteristics. And then match them off 2 at a time. One gets one treatment and one gets the other. The other way that happens is another way you can get a match pair design is if you give each experimental unit both treatments, but you give them in a random order. So that's another way that you can get those blocks of 2. Okay, so match pairs design is, it's a great method for experimenting, but again, all of these methods just include more steps, more effort, and where there's more steps needed and more effort that takes place, there's usually more dollar signs involved, and a lot of companies have a hard time doing that. So running a good experiment, running a very thorough and a very detailed and a very strong experiment is usually really expensive. So that's just one thing that companies have to encounter when they're trying to develop an experiment that's going to carry weight, that's going to have good results at the end. Okay. So there's a couple of designs for you, randomized block and then match pairs design, which is truly a randomized block design. But those are some more detailed, some more specific experimental designs for you, but you will see those throughout the rest of this course. All right, we are finally at the end of section 4.2, and I really appreciate you guys hanging in through all of these crazy pieces. This experimental design stuff is important to understand before we get into the testing component, which starts in about chapter 6 and takes us through the end of the year. So this is a really good piece for us to know, and you are likely to have to design an experiment or come up with some sort of experimental design on your AP exam. That is likely to be one of the components of your free response section. So these are all important terms for you to know and understand. So thanks for listening, and tune in next time.